Okay, what you're looking at here is a screenshot from Desmos, and we're going to take a look at a couple inverses, y equals 2 to the x and y equals the log base 2 of x. It's very important to understand that these two functions are inverses because we need to use this fact when we solve equations that involve logs or exponentials. The rule of an inverse is that one function undoes the other one, or they cancel each other out. And we'll make that more apparent on the next slide. But one of the ways these are described is one graph is reflected over the line y equals x. So if you look at 2 to the x in red, and you look at log base 2 of x in blue, they are mirror images of each other. You consider the green line to be the mirror. Now we're looking at just the two graphs, the two inverses themselves. So the red graph is still 2 to the x, and the blue graph is still log base 2 of x. If you look very closely at the points and how they match up, notice that every y value on the red graph is an x value on the blue graph. So that's another common association with inverses. If any point, any x and y, lie on one graph, then those points need to be reversed and end up on the other graph. Otherwise, they're not true inverses. So this is literally what it means to cancel out. One function x goes to y, and if you plug that into the other function, well, y goes back to x. You're right back where you started. Another thing to keep an eye on is the fact that as the red graph goes into the negative values of x, the blue graph goes into the negative values of y. They don't have the same exact domain and range. But what is interesting is that the range of the red graph is the domain of the blue graph, and vice versa. The domain of the red graph will end up being the range of the blue graph as well. So that pretty much sums it up. Look to your notes on finding inverses and graphing, but this will be the next thing we do. So look for another video where I pull up some more inverses and we break it down a little bit. All right, have a good day.